Hello, welcome to my GCSE Science. So far in this energy changes topic, we've mainly been looking at ways in which chemical reactions convert chemical energy into heat energy, or vice versa. But in these next two videos on chemical and fuel cells, we're going to be looking at how chemical reactions involve changing chemical energy into electrical energy, which we can then use to power our gadgets, cars and homes. In order to understand how a chemical cell works, we need to remember the reactivity series. Because a simple chemical cell involves two metals, one which is more reactive than the other, and it's this difference in reactivity that creates the electricity. So let's look at how this works. This diagram on the right might remind you of electrolysis, and it's a similar sort of process. But unlike electrolysis, which requires an input of electrical energy, this chemical cell doesn't involve connecting to a power pack or power supply. All we've got are two metal rods, in this case a copper rod and a zinc rod, and they're dipped into a salt solution. In this example, as zinc is more reactive than copper, the electrons flow from the zinc to the copper, and the amount of electricity produced, or voltage, depends on the type of electrodes and the electrolyte used. The greater the difference in reactivity between the two metals, the greater the voltage that will be produced. So we can write a chemical equation for this reaction that looks just like a displacement reaction, because it's basically displacement that's going on here. And if we divide this full equation into two half equations, hopefully you'll recognise that one half of the reaction is oxidation and the other half is reduction. In this case, the zinc is being oxidised because it loses electrons, and those electrons then pass around the circuit to be gained by the copper, which is reduced. And although we've used zinc and copper here, in theory we could use almost any metal, as long as it's not so reactive that it reacts with the water in the solution. So you might be wondering how this beaker containing two metal rods in a salt solution can help you power your phone, your flashlight, or something like that. So let's look at how this relates to batteries. A battery is basically a name for a cell. Strictly, a battery is a series of cells that are joined together to produce more electricity. Although the battery is completely enclosed, it still has electrodes and an electrolyte, like we had a minute ago. In the case of this zinc-carbon dry cell, the electrodes are zinc, which is the negative electrode, and carbon in the form of graphite, which is the positive electrode. And this is called a dry cell because rather than having a solution sloshing about, the electrolyte is actually a paste. The paste means it's solid enough that it won't leak, but it's liquid enough that the electrons can still move around inside and do their job. This zinc-carbon dry cell is an example of one of the first batteries that was produced. And it's non-rechargeable, which means once all the reactants are used up, then the chemical reaction stops and we can't get any more electrical energy out of it. More recently, we've developed alkaline batteries, which you may have heard of. This is another example of a non-rechargeable battery, but it's able to produce a higher voltage than the zinc-carbon traditional cell. But as you know, we can also have rechargeable batteries. In a rechargeable battery, the reaction can be reversed by supplying an external current, i.e. plugging it in. This allows the battery to be used again and again. We use up the reactants until no more energy can be produced. Then we plug in our rechargeable batteries so that the current can reverse the reaction, and when it's ready we can start the whole process again. Examples of rechargeable batteries are lithium-ion batteries, often used in cameras, and nickel-cadmium batteries, often used in mobile phones. And that's it for chemical cells. The next video is about fuel cells, so make sure to catch that. But for now, here's a summary of the keywords for this video. I hope you enjoyed it, and see you again soon on another video by My GCSE Science.